So, we can start. Let's see an example where we have a data set of the rainfall details of Indian states through a year. Every month in Tamil Nadu, for example, how much has been the rain throughout the year. So, we have a data set like this where it shows yearly data. In the past 200, 300 years, if you look at it, it's very interesting to note that it's only by data we come to know that on an average, we get 4,000 meters of rainfall across India. It's actually ample rains. Even though many parts of India is having water shortage, there is enough rainfall for the country and people to survive. So, this kind of data set will be of help for us to do planning for the government also and for the people to understand that rainfall will be of help for us wherever there is water shortage. If you can harvest rainfall, then a lot of things can change in terms of water shortage. Even if there is ample rainfall, why should we have in villages in Tamil Nadu, for example, why should we have water shortage? Because people mindlessly, they use borewell waters, underground water, and the rainfall is not stored anywhere, it just flows away or it stays at the top surface, and when there is hot season, all this surface water evaporates. It doesn't percolate down to the underground water table. Therefore, rainfall data set is very important and crucial at this stage for our country. For every country, it's very important. Water is very, very crucial. So, if you look at the data, there are things like if you have, some places you have data in millimeters, in some places it is recorded in centimeters, it is recorded in meters. Okay. So, you have to do a scaling. You have learnt and heard about the scaling of data. You have to have a balance on what is the format in which the data is available across all the states. The entire data set data should be in the same scale. Then in case you have you can have two types of data. One is numbers, the other one is names. For example, in the morning we saw iris data set. So, the flower name, instead of the flower name, we encoded it into a number. So, 1 or 0 is one hot encoding. Label encoding is where you give numbers to particular labels, particular types. So, that way all those are used here, as well as there is one more important thing. Do you think that rainfall in Kerala has an influence on rainfall in Tamil Nadu? Especially living in Ettimadai, we should know that whenever there is rainfall in Kerala, it's in the western Ghats, and the remaining rainfall actually comes to Ettimadai. Is there a relationship between how rains are coming during January, February, September, October, June, July? There is actually a relationship. You call that as the correlation, and you can calculate this correlation to understand from January to December, January to February, March, April, is there a relationship among the features in each data point? The column wise data, do they have any relationship? We do it using the heat map correlation matrix. This is another point. This kind of plot, you call it as the box plot. Actually, what it tells is, if you compare Tamil Nadu rainfall with Darjeeling rainfall, it is unfair to compare, because throughout the year you have rainfall in Darjeeling and Tamil Nadu has a different set of characteristics. So if you, actually if you want to compare them, then you should actually tweak the data so that they become comparable. And you should also understand that Darjeeling is largely an outlier in India. The rest of the states have a normal rainfall, where Darjeeling is an outlier. So to find out outliers in every column, for example, you can actually create a box plot, and box plot actually what it does is what values come within, let's say the range is from 1 to 100. Between 25 to 75 is normal range. The others are outliers. So which values in your column, the one particular feature. So here it is 12 features, January to December, 12 months, 12 features we have. So every feature, what outliers it has, you have to remove them from the data so that it does not influence the trend in the data we have. Normal data we should take and analyze the trend. If you have outliers, the trend will be actually deflected and you won't get the correct trend or pattern in the rainfall. So outliers you have to analyze before we use the data set for regression or classification. Now after this is one thing I promised, that we will have a short discussion on K-means. Whatever we did till now was supervised learning. When you say supervised learning, you have input data and the target output is also given to you. Here in this case, we want to categorize the states into multiple clusters. These states have low rainfall, these states have high rainfall. Let us say only 2 clusters we want. And among these 2 clusters, we don't know which one is having high and which one is going low. Depending on the given data, we want to group them, create them into clusters, create them into groups. That is what K-means algorithm allows us to do. What it does is, you will just randomly select 2 states and tell that they are the leading states in group 1 and group 2, low rainfall group and high rainfall group. Let us say Tamil Nadu is a group leader in low rainfall group, and West Bengal is a group leader in high rainfall group. Let us say we choose. It's a random choice. There is no logic in specifically choosing. Random choice you make. After that, depending on the rainfall data, you will start finding out groups among the entire set of states. We have around 31, 32 states. So they should be divided into 2 depending on how much rainfall they have. So initially, with group leader Tamil Nadu, some of the states rainfall will come, and after that West Bengal. You don't know if it is Tamil Nadu and West Bengal which is the lead in these 2 groups. You randomly select. This is what we did with linear regression also. We chose M and B values random in the beginning, then we learnt to understand, but then we had a target value to calculate the error. So here there is no such error calculation. You don't know the target value. You don't know which category each state falls into. So you call this as unsupervised learning. So you start with random and form clusters. Once you form the group, then based on the data, select the average or mean or the center value. Then it may not be Tamil Nadu, it could be even Andhra in the low rainfall group. In the high rainfall group, maybe it is Haryana or Kashmir. Then again, you have to recluster the entire group of 32 states. So like this, you will keep continuing until you find that, you can do it. This is like your epoch. First epoch, second iteration, third iteration, fourth iteration. So you stop at one point and say, these are the states in the high rainfall group, these are the states in the low rainfall group. So this is unsupervised learning, and this is also a kind of learning. This kind of learning, do you think will it be useful in the internet? If I want to move across the internet about what kind of information do I get on artificial intelligence, let us say. There is a lot of information in the internet. I want to group them into beginners level and advanced level artificial intelligence materials or blogs, articles, news articles, magazines, books, so many different types of information is available. You want to classify them into two groups, beginners level and advanced level. Now if you look at it, you already do not know whether it is beginners or advanced level in many cases. Only by reading through the article you will be able to do that. If you can collect some features like this, some keywords that can classify a particular document. So document classification, web blog article classification, text classification is a big area used in machine learning. You will have to choose things as features based on which you will evaluate a particular article. So if you can do that, how do you choose these features for a given problem is going to be the real challenge. Once you do that, you have your data set. Once the data set is available, either it is supervised or unsupervised, you will be able to create groups, you will be able to classify them into different groups, and you will be able to understand. Can you tell me any problem where machine learning can be applied in your domain? Maybe from ECE or EEE, you're all from different backgrounds, right? Can you tell me one problem where machine learning can be applied? Cancer detection. So that is one example I'm going to show. Cancer detection is where you will have a lot of clinical parameters as data set for the patients. Looking at the data set, you can segregate them into clusters, multiple clusters for different stages of cancer. I'm going to show that. You can apply k-means clustering algorithm for that. It's one of the simplest algorithms to create groups. It's very powerful algorithm. The k is the number of clusters. And that k, for a given data set, you will find out which k is the best. Into how many groups the data points can be classified or segregated. That k, what is that k? You will identify by iterations. That is the learning that you will be doing. For EEE, let us say you want to identify a fault in your instrument. You continuously find out, for calibration of the instrument, you want to identify different parameters in the working of the instrument. You keep continuously taking these values. So let us say even sensor data. You continuously take sensor data. At the end of it, after a period, you will see that you have a lot of data. From that data, you realize that you need calibration for the instrument. So you have to predict calibration is required or not. It is not a classification problem. We will take it as a prediction problem. Based on the sensor data from the instrument, we will decide whether a calibration is needed or not. So your data set will contain, for these values are sensor values for the instrument, you have to do a calibration. For these values, you need not do a calibration. You did calibration 10 times before, so you get 10 data points. 10 data points plus another 10 data points where you didn't need calibration before. Only if you know both positive and negative cases, you will be able to predict correctly. In case you want to find out the number 2 groups in a given data set, as in here, you want to find out, you should have in both the groups equal number of examples. Ideally, you should have equal number of examples, but that may not be the case always. AIDS patients, let us say 100 patients data you have, but you will have 1 lakh patients data without AIDS. Those who went through the test for AIDS, but then they did not have positive result for AIDS, only 100 patients. So in critical cases like that, it is very difficult to have equal number of positive and negative cases for the learning purpose. But still, that will help. Machine learning will definitely make maybe you will get an accuracy of 70%. There are problems where you will have accuracy of even 50%. You can crawl through the internet and get a lot of information. There are a lot of problems you can get. You go to Flipkart and try to buy something, you get a lot of recommendations. Let's say you want to buy a mobile phone, accessory recommendations will come. How do they get it? They have already learnt from customers before, each customer what kind of items they bought. If they bought a mobile phone, what else did they buy? That associations, the combined group of products that a customer buys, they have a list, that becomes your data set. If you have a problem, you can identify what can be the data set. So formulating the data set is done by a data scientist. A data analyst will do all the pre-processing, like do you have outliers, do you have missing values, do you have to do a scaling, do you have to do all the cleaning of the data. So give a raw data set is given to you means you have to first clean the data. You have to make it ready and then go for machine learning algorithms. The correlation map, which is a heat map, it is done across every month data to every other month. So you have it's like an adjacency map. The highest correlation is in the diagonal and lowest correlation is away from the diagonal. And it all depends on dark areas show high correlation. Dark areas show low correlation and bright areas show high correlation. Go up. This data shows that 899 centimeter rain was actually predicted, whereas the actual data was 931. In case you have data for 2001, 2, 3, 4, then 9 and 10. So 2006, 2007, 2008 you don't have data. That missing gap, can we fill it? Right? See, many times we miss documents, we miss data, this is very common. You can always do it. You do a prediction with data from 2001, 2002, 2003, 2004, 2005. Make a prediction. Give a mathematical model, a straight line, regression analysis you do. Then do a prediction for 2006. Do a prediction for 2007. You compare your result with the other way around also. 2009 and 2010 again make a trend analysis. Have a mathematical regression analysis. Then compare this result to see what kind of prediction you have done for 2006 and 2007. So you can always fill in the missing data. So this is regression analysis on the rainfall data. You can predict how much rainfall you will get next year. Based on past 100 years of data, you can predict what kind of rainfall you are going to get next year. It is possible. But it is always possible that you are not going to be exactly right, and the error that you are predicting can always go up. Last year, we had very, very poor rainfall in Etimadai. But in the past 1.5 years, we are having very good rain. Last week, in one day, we got 13 centimeter rainfall. So those things are not in our hands because of the climate change. But how is this climate change affecting rainfall? You can make a study based on this data set. Next data set. Next data set. Cancers. Close. Cancer cluster. Just go up a little bit. Just go up. So we have a cancer data set, we have clinical parameters for the cancer data set. You can actually see it, we will share the notebooks. But then two types of clustering algorithms were used. One is k-means clustering. the other one is hierarchical clustering. In both ways, we could segregate cluster of patients in the given data points. This is the actual clusters. K-means gave us this result. This unsupervised learning, okay? The algorithm is unsupervised. So we did not, actual data we did not supply for the training, but still you could compare it when you know the actual data to see how the algorithm works. It is very close. You can see that it is very close. It's not a bad prediction. It's not a bad clustering algorithm. Come down. Hierarchical clustering is not doing well for this data set in comparison to the k-means algorithm. Well, that doesn't mean hierarchical clustering is always not performing well. It depends on the data. It depends on the numbers that you have in your data points. Current data set, k-means is working better. That's what it means. So you apply two algorithms, usually one or two classification or prediction, regression analysis algorithms, clustering algorithms you will apply for a given data set and choose which one is better. If you are not, most of the times that is how we choose a particular machine learning tool. Next one. The third one is animation of k-means. Third one I am finishing right now. The third one is you can see an animation of the k-means clustering, how it is happening. Actually it takes time to run, therefore you can test it. It takes time. Actually I have tested it once, but then it takes time, therefore you can test it offline. The entire code is available. Why I have chosen the animation is, you know, the Python code, how to show animation is also available. So you can use that for your testing. Around 12 clusters are created for the given data set. You will not be able to run it within this time, but so you can. So I am stopping here, and we can continue with more examples, hands-on examples, and all the best. I hope you had a good time here in the workshop, at least some introduction to machine learning, some basic idea in machine learning you have got, and a few algorithms you have heard. We were not able to cover all the algorithms because of your background. That doesn't matter. You can continue subscribing to our channel, Sigma Lab channel, and if there is any request for specific algorithms, you can always send us a mail. All the best.